Good afternoon to all. I am Amika Kurajani, Assistant Professor of CSC Department at SIT Bhopal. The subject name is Theory of Computation, and today's topic, which we are going to start, the introduction of TOC. So let's begin. Now, what is the theory of computation? As you can see, the theory of computation is made up of the two words, that is a computation and theory. The computation basically what does exactly mean? Any calculation or any task performed by the machine like calculator and computer. So these tasks is basically known as a computation. And these computation are used to represent the various mathematical models like finite automata, PDA, and the Turing method, which we will discuss in the further lectures. And theory means what are the capabilities of these machines, what type of problem they can solve, and what are the limitation of means what problems they cannot solve. So basically, if we say the automata theory is the theoretical branch of computer science and mathematics, which mainly deals with the logics of computation with respect to the machines, which also known as the automata. The automata basically enables the scientists to understand how machine compute the functions and solve the problem. In short, if I can say, the TOC is a subject in which we study the abstract machine. Now, in short, I can explain with some more questions which the TOC tries to answer the following question. Means what type of mathematical properties of computer hardware and software have? What is a computation? Can we rigorously define the mathematical definition of these notation? What are the limitations of computer? Can everything can be computed or not? Uh, what is the purpose of TOC? TOC is basically used to develop the formal mathematical model of the computation that reflects the real world computer, and what the main purpose is to determine in a TOC what can and what cannot be computed, how quickly and how much memory is required to design the finite automata, and what on which type of computational model is used for designing the any automata. Now, as you can see the TOC history, the Alan Turing is also known as the father of the TOC. He has given the concepts of Turing machine, what type of the mathematical models we can design for the real world computers. The Alan Turing studies the Turing machine, decidability problems he has defined, and halting problems. In year 1940 to 1950, the Chomsky also proposed the Chomsky hierarchy for the formal languages. In 1969, Cook also introduced intractable problems and NP-hard problems. What type of NP-hard problem, which we will cover in the fifth unit. And in the 1970, the basic evaluation of TOC involved means what type of computer science compilers are designed, computation, complexity theories, concepts are evolved till the day. Now, question arises why we study the TOC. As you can already know that it is a fundamental subject for the CSIT in a university and many competitive exams. In the gate, 8 to 10 marks out of 100 marks on an average, the 6 to 7 questions come in the from the TOC in the gate exam. In a net exam, 7 to 8 questions come from the TOC subject. The automata theory is basically the foundational course about what the capabilities, what are the limitations, what are the fundamentals of computer. We are basically learn and teach in this subject. It is about the mathematical properties of computer hardware and software. It basically helps you learn the problem solving skills. Theory teaches how to think, argue, solve the problems, and how to design the abstract mathematical models. It also allows to think the systematically what the machine can do without going to the any hardware details. As we will also learn the basics tools like regular expression, grammars, which help in designing the solution to many complex problems. Means through this subject you can also capable to design the compiler, string searching, pattern searching, and new programming language. All the real life applications where these types of TOC concept is used. Now let us I would like to give the real life example of TOC where this concept is introduced in their daily life. Like in a sequential machine, this is also the mathematical model of the certain types of computational structure. Basically the behavior represent the working process of the finite automata. The traffic light signal, where the optimization of the traffic light controller in a city is a systematic representation of handling the instruction of traffic rule on the basis of TOC. As you also seen in the vending machine, you have the so many dispenses, numerous items such as cold drinks, snacks, beverage, alcohol. Vending machine basically work on the finite state automata to control the function process. In the text parsing, video games, regular expression, matching, speech recognition, in all these applications, we are using the concept of the TOC. Now, there are three types of computation, theory of computation: the complexity theory, computability theory, and automata theory. Not what exactly they are. The complexity theory means what makes some problem computationally hard and other problem easy. As we can say that the researchers are still working for more than the 40 years, but we don't know the answer to it. I mean, how we can consider the problem is hard and other is easy. But if informally we are saying that problem is considered be easy if it is efficiently solvable. Like if we want to sort the sequence of 10,000 numbers, so we can easily solve that problem. So that problem can be considered as a easy problem. Suppose on the other hand, which problem cannot be solved efficiently, or we don't know how we can solve that problem efficiently, like factoring the 300 digits integer into the prime factor, and that problem can be considered as the hard problem. So, and at last we can say the complexity theory basically classify the problems according to the degree of computational difficulty by giving the rigorous proof that certain problems that seems to be hard and that are some problems to be easy. Okay, so we can basically learn the what problems can be considered as a hard and other problem can be considered as a easy in the complexity theory. Now, computational theory is basically which problem can be solved by the computers and which cannot be solved. Like uh, now we will consider that the Alan Turing and Chur discovered that some of the fundamental mathematical problems cannot be solved by the computer. For example, suppose I want to determine whether the mathematical statement is true and false. So it seems like the natural for the solution by the computer, but there is no such computer algorithm can perform this task. So this problem cannot be solved by the computer because there is no computational algorithm is available. The theoretical model were proposed in order to understand solvable and unsolvable problems led to the development of the real computation. So in short, we can say that the computable theory classified the problems as being solvable and the unsolvable. Last, what the type of computation is automata theory. So this automata theory we will cover in this subject in very deeply and thoroughly. The automata theory, in short, I can say that in this we will learn the mathematical models of the computation, like finite automata, which are used in text processing, compiler designing, hardware designing. Context-free grammar are basically used to design the programming language, and it is also used in some applications are also used in artificial intelligence. Turing machines basically form the simple abstract model of real computers such as your PC, which you are using at home. So at last I can say the automata theory basically determine the power of different computational models, which model can solve the more problems than the other. So we have discussed the dif- different types of the introductory class of the TOC and different model of the TOC. Thank you so much. Stay tuned. Keep learning.